So just here's some examples. If we look in the periodic table at hydrogen and add two hydrogen atoms together, we get the mass of a hydrogen molecule, or so-called molecular weight, is 2.016 atomic mass units. And we can also interpret that as being 2.016 grams per mole. And we can write this: 2.016 grams of H2 is equal to 1 mole of H2. And you see, this is going to come up as a conversion factor later. Or the molecular weight of CO2 is 44.01 atomic mass units. We get that by adding the mass of one carbon atom and two oxygen atoms. We get 44.01, but we can also read that as 44.01 grams per mole, or 44.01 grams of CO2 is equal to 1 mole of CO2. Or the formula weight of sodium chloride is 58.44 atomic mass units, meaning one formula unit weighs 58.44. And from that, we can infer that 58.44 grams of sodium chloride is equal to 1 mole of sodium chloride. These things now allow us to do conversions. Remember how whenever we have an equality like that, we can put it into a conversion factor and convert from one unit to another. And this allows us to convert between two different ways of expressing the amount of a substance. We can express the amount as the mass in grams, or we can express the amount by something akin to counting the atoms or molecules in moles. So here's an example. How many moles of water in 10 grams of water? Well, we get this relation from looking up the molecular weight, adding two hydrogens and an oxygen. We get 18.01 grams of water is equal to 1 mole of water. Then we can do the calculation like this. And just remember how this works. This equation goes into a conversion, and we choose the convert with one side in the denominator and one side in the numerator. We choose the conversion in such a way that we get units to cancel. And our final unit of the answer is moles of H2O. And so we've answered the question essentially as a unit conversion. Here's another example. What do 2 moles of sodium chloride weigh? First of all, I express the calculation of the formula weight. The formula weight is just adding sodium and chlorine from the periodic table. I get 58.44 for a formula weight. And remember that implies one formula unit is either 58.44 atomic mass units, or 58.44 grams of sodium chloride is equal to 1 mole of sodium chloride. I do the calculation by starting with 2 moles of sodium chloride, multiplying by the conversion factor. And again, we see the conversion factor comes from here, goes into this ratio, and I put 1 mole in the bottom because I want moles to cancel, and I get this answer, 116.88 grams of sodium chloride is the same thing as 2 moles of sodium chloride. And here's another example. What's the mass of a single CO2 molecule? I should point out that this is a very common mistake that students make when we're going from grams to moles and looking at individual molecules as compared to moles of molecules. The mistake, well, first of all, we look up the molecular weight of CO2, 12.01 for the carbon, 2 times 16 for the oxygen, we get 44.01. A very common mistake that students will make is to say that the mass of a single CO2 molecule is 44.01 grams. That's just not true. You should have an idea of what 44 grams is. It's about, say, 44 milliliters of water is something that weighs 44 grams. You should know that a single CO2 molecule does not weigh 44 grams. So how do we get the mass of a single CO2 molecule? Okay, first of all, here's some conversions. 44.01 grams of CO2 is equal to 1 mole of CO2. But a single CO2 molecule is not 1 mole of CO2. 1 mole, remember 1 mole is really this very large number, 6.022 times 10 to the 23rd. How do we get rid of that mole unit? Well, we use 1 mole of CO2 is equal to 6.022 times 10 to the 23rd molecules of CO2. Here I use, notice MOLEC to stand for an abbreviation for molecules. Now with these conversions, now I can do the calculation. I start with 1 molecule CO2, as I've shown here. Then I use this conversion to turn molecules into moles. So 1 molecule, so 6.022 times 10 to the 23rd molecules of CO2 is equivalent to 1 mole. Molecules cancels, now I'm in moles. And I use this conversion over here to convert moles into grams, with a mole in the denominator, grams in the numerator. And the answer I get, 7.308 times 10 to the minus 23rd grams CO2. So I get a very small number. You should know that, you should recognize this, you should know that a molecule of CO2 is extremely small. All atoms and molecules are extremely small, so I expect to get an extremely small number. Please pay attention to magnitudes. I know I should get a small number. Sometimes we'll see students try to do this calculation and multiply by Avogadro's number instead, and they get a very large mass, and that's simply wrong. So you should know that the answer to this question, if I'm doing it in grams, is just a very small number.